Why is there a need to simplify a Boolean expression, and what is the main advantage of simplifying Boolean expressions? Simplifying Boolean expressions provides less components. It's faster and it generates less heat and is cheaper to make. Given the example on the video posted, we can see a complex combination of the stream of where the input flows, the paths and the gates. Now, this complex expression can still be simplified, which will then prove to be more efficient because the input will now generate an output at a faster speed because it travels to lesser paths. In this sense, when there are lesser paths, lesser on and off by the transistors will be done, which will lead to lesser heat generation. And in what way can this complex combination be simplified? It can be simplified in this simple way. Before, it has a longer process for the input to provide an output. But now, even though they have different expressions, as earlier was a longer one and this now is a shorter one, this still provides the same outcome with lesser processes. Thus, now that it has lesser components, it is now cheaper to make. What are the bases of Boolean algebra and how does it operate? An algebraic system developed by George Boole in 1854 and the switching algebra by Claude Shannon. With this, the postulates formulated by Huntington provides how this operates, and if these postulates are satisfied, it is considered to be Boolean algebra, wherein postulate 1 can be summarized in a way that both the operations and or produce an output of either 1 or 0 for all combinations. Postulate 2 means that element 0 is an identity element with respect to OR, and 1 is an identity element in respect to n. Postulate 3 is the commutative property, which means that even if the x and y columns are swapped, the results are unchanged. Postulate 4 means that either AND or OR operators can be distributed over each other, unlike in base 10 algebra, wherein the distributive property can only be applied in multiplication. Postulate 5 means that there exists a complement for every element, and postulate 6 states that 1 cannot be equal to 0, which as by definition it really can't be. On the numbers and expressions used, Boolean algebra uses letters to symbolize an undefined value, which may only be either 1 or 0. On the other hand, base 10 has a wider scope, which ranges from integers and other number systems, which may use thousands or millions. Next, binary operator plus defines addition, whereas on Boolean algebra, the plus symbol defines an OR. Next, the binary operator dot defines multiplication, whereas on Boolean algebra, the dot symbol defines an AND. Last difference I'm going to mention is the distributive property on base 10 algebra and Boolean algebra. On base 10, the distributive property can only be applied by the multiplication over the addition, whereas on Boolean algebra, the distributive property can either be applied by the addition over the multiplication or the multiplication over the addition. For their similarities, both of them uses a letter to represent an undefined value. Boolean algebra does not have additive or multiplicative inverse, therefore, there are no subtraction or division operations. Postulate 5 defines an operation called the complement, which is not available in ordinary algebra, but the closest to this one is the additive inverse. What is the difference between a standard form and a canonical form? When they use one over the other? Canonical forms are forms derived from reading a given function from the truth table. These forms are very seldom the ones with the least number of literals because each minterm or maxterm, by definition, must contain all variables. On the other hand, standard form, the terms that form the function may contain one, two, or any number of literals.